Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 8.2, day 2, entitled Graphs of Polar Equations. And in this section of notes, we're just going to take a look at some more advanced type of polar equations that we can graph, some of those different shapes besides the circles and the lines that we got in the previous section of notes. And this first one that we're going to start off with is actually called a cartoid. It kind of looks like a heart. And then the other one that we're going to do is going to be one of the rose patterns. Now in 8.2 day 1, when we were starting off with some of the basic graphs, we converted them from polar into rectangular coordinates so that we could see that they were circles or lines, but we're not going to do that here. We're just going to make our table of values with r and theta, and then we'll graph on our polar system. So here, this graph is r equals 2 plus 2 cosine theta. So I'm going to make my table of values. And yesterday when we did this very first graph in this way, I was really thorough, used lots of points as we go around the unit circle, but that can be really time consuming. So from now on, just kind of as a shortcut, just stick to picking the fourths or the halves or the axes. And by that, I mean pick pi over 4, pi over 2, pick 0 and pi. Okay, so just go like every quarter of a pi around the unit circle, especially if you have to go from 0 all the way around to 2 pi, which is what we're going to have to do here. So we would start with 0, and then we would go to pi over 4, and then pi over 2, and then 3 pi over 4, and then pi, and then we need 5 pi over 4, and then 3 pi over 2. And I'm going to run out of room, so I'll extend this just a little bit. Okay, so 3 pi over 2 gets me over here. Then I'm at 7 pi over 4, and then I'll be at 2 pi. So just go every fourth of a section as you go around the unit circle. Okay, that'll be thorough enough if you have to go from 0 to 2 pi. So then remember what we need to do is we need to take all of these theta values and we need to substitute them into our equation. So I'm going to take the cosine of theta at these radian measures, find that value, then I have to multiply it by 2, and then I have to add 2 to it. So really pay attention to your order of operations here as well. Okay, so cosine of 0 is going to be 1, and 1 times 2 is 2, and then 2 plus 2 is going to be 4. So if you need to do a little scratch work off to the side, that's okay. Let's see, for pi over 4, the cosine of pi over 4 is square root 2 over 2, and then I have to multiply that by 2, which is going to be square root of 2. Then I have to add 2. So that's really 2 plus the square root of 2, but I'm going to write it as a decimal, 3.41, because I'm going to have to plot that distance on my polar coordinate. So I want to know about how long that little segment's going to have to be. Okay. For pi over 2, the cosine of pi over 2 is 0, and 0 times 2 is still 0, and then when you add 2 to that, you get 2. Right, 3 pi over 4 now, that should be similar to what we did with pi over 4. It's just going to change the sign. So cosine of 3 pi over 4 is negative square root 2 over 2. If I multiply 2 by that, I get the negative square root 2, and then I have to add 2. So it's really like 2 minus the square root of 2. So that gets me a different decimal, 0.59. Okay, pi should have the same value as 0. Oh, no, it won't. Sorry, when I substitute pi in, the cosine of pi is going to be negative 1. Okay, so it's almost like 0. We're just changing the signs. Okay, and then we're going to multiply by 2, so that's negative 2. And then we add 2, so we get 0. So initially, when we substituted in the values for pi and 0, and here. We took the cosine of them. We got 1 and negative 1. So same value, just changing the sign. 5 pi over 4, the cosine of 5 pi over 4 is negative square root 2 over 2. And then we're going to multiply that by 2 and add 2. Now that's exactly the same thing as I got over here for 3 pi over 4. Okay. So that's going to be 0.59 again. 3 pi over 2, cosine of 3 pi over 2 is 0 again. And then I multiply that by 2, which is still 0, and then I add 2, so I get 2. So again, that is exactly the same as pi over 2. So now we're going to see our pattern repeat here. Okay, so 0 pi is kind of, like when we talk about parabolas, we say that that's like the vertex, and then you see that pattern repeat on either side. So it's kind of that same concept. Okay, I mean, we're not graphing a parabola, but it's kind of that same concept, how this is like our middle at 0, and then the pattern starts to repeat above and below on either side of it. So our next value here then should be the 3.41. So let's double check it. 7 pi over 4, if I substitute that in, take the cosine of it, I get square root 2 over 2. And then I have to multiply that by 2, so that's a square root of 2. Add 2, so I have 2 plus the square root of 2. That's, again, what I had over there, 3.41. And then 2 pi will be the exact same as 0 because it's the same location on the unit circle. Okay, so now that I have all these values, now I just need to go through and I need to graph it. So remember, we're kind of graphing backwards here from our table. Okay, I'm going to start at 0 degrees, and I'm going to do a segment that's 4 units long. 1, 2, 3, 4. And then I'm going to go to pi over 4, and I need a segment that's 3.41 units long. So just kind of estimate where that would be. At pi over 2, I need a segment that's 2 units long. So I'll connect these in a moment, but just know that you have to start at 0 and go around. So I'll connect them in a moment. 3 pi over 4, I'm going to need a value that is 0.59. So that's about halfway. It's a little hard to see on the screen here. Right about there, perhaps. And then at pi, I'm going to be at 0, so I'm at the origin now. So since I've gone halfway, let me connect my points. Okay, and you're thinking, gosh, Mrs. Miller, you said this is supposed to be a heart. It's called a cartoid. It's supposed to be a heart. I don't see it. We'll see it as we complete the rest of it. Okay, 5 pi over 4 then is over here, and I need another segment that is 0.59. 3 pi over 2, I need a segment that's 2 units long. 7 pi over 4, I need one that's 1, 2, 3 and a little bit. And then at 2 pi, I come back to the 4. So now when I connect this, you want to connect these with curves because they are supposed to be curved. There we go. So if you rotated this around, if you rotated it 90 degrees to the right, this part here would be the top of the heart. And then you'd have the bottom of the heart here at 0. So it kind of is like a little heart sitting on its side, kind of like that. And it's not the exact shape of a heart, but it kind of is supposed to represent that. Okay, so your book, when it describes how to graph these, it wants you to go through and think of your sine curves or your cosine curves, your cosine curve in this case. And again, it's doing every half value. We did every fourth, okay? I think they have the fourths in there. They're just not marked. And then these are the values that they got out. I don't want you to actually make that actual sine or cosine curve graph like they have it here. Just use your unit circle to get those tables of values, okay? And that's what they're trying to represent here. And then they're going to graph it piece by piece here. So they've graphed the first few points in the first quadrant. And then they go around to the second quadrant. And then they go around to the third quadrant. And then they complete it into the fourth quadrant. Okay. And you can read through those explanations if you want, but it just talks about how you have some parts that get reflected into different quadrants as you graph, which you know that. You know where the different quadrants are. You know that some of the graph has more in one quadrant than it does in another. That's okay. But remember that all of these cardioid graphs that we're going to be dealing with that have the heart shape, they're going to follow this format in either sine or cosine. Now they're not going to have a plus minus in the equation. That's just to remind you that you could have a plus there or a negative there. Same thing for the sine. Okay? So our equation that we had for example 4 was 2 plus 2 cosine theta. So if we put it into this traditional format, we would take out the value of 2 as a GCF, and then we would have 1 plus cosine theta. Okay. So again, that A value is supposed to be like the radius, and in the cartoid, it's hard to see an actual radius value. Okay. But if you wanted to rewrite the form, you could. You could still substitute your values in for theta, evaluate the cosine of theta, add 1 to it, and then multiply by 2. So whichever format you want to work with is totally fine. I think it's just easier just to take the equation as the way it's given and just substitute in there and work with it the way they gave it to you. But if you want to take out the GCF so it's in this traditional format, you can. Okay, let's try one more. This time we're going to graph a rose, and it's going to have 4 leaves on it. So it says in the top here, 4-leaved rose. In the next couple of slides after the graph, we'll talk about how you can know if it's going to have an even or an odd amount of leaves on the rose. So when we're graphing this, we have r equals cosine 2 theta, and really this could be written a different way, and that might be a little bit easier for us to work with if we rewrote the equation, because cosine 2 theta is a double angle. So it's easier if you think of that in terms of what the double angle actually means. And one of the equations for the cosine 2 theta is 2 cosine squared theta minus 1. So I recommend that you substitute any double angle for a squared equation. So that way you can plug the number in for theta, take the cosine of it, square it, multiply it by 2, subtract 1. That's more familiar calculations for us. But again, we're going to make our table of values from r and theta. And we're going to start at 0, and we're going to go all the way around to 2 pi. But again, we're just going to pick every fourth. So you'll get really good at knowing these values. If you make these table of values over and over and over, you'll kind of memorize the order that you go around. So you won't have to count every time, or you won't have to look at your unit circle to find those values. We have 3 pi over 2, 7 pi over 4, and then 2 pi. So again, go every fourth of a section as you go around the unit circle or as you go around the pole. And then we're going to take these values one at a time. We're going to substitute them in for cosine, square them, then multiply by 2, then subtract 1. So again, if you need to do a little scratch work off to the side, that's okay. So if I take the cosine of 0, that's going to be 1. So I'll really have 2 times 1 squared minus 1. So 1 squared is 1, times 2 is 2, minus 1 is 1. Pi over 4, That's going to be square root 2 over 2 for the cosine. So I'll have 2 times the square root of 2 over 2 squared minus 1. So if I take the square root of 2 over 2 and I square it, I'm going to get 2 over 4. And then I have to multiply that by 2, which will be 4 over 4, which is 1. And then when I subtract 1, I get 0. Okay, for the pi over 2, the cosine of that is going to be 0. So 0 squared is 0, times 2 is still 0. 0 minus 1 is minus 1. So far this is pretty nice because I'm getting whole numbers. And they're all zeros and ones. Okay. 3 pi over 4, that's going to be another square root 2 over 2, but it's going to be negative. So I'll have negative square root 2 over 2. But when I square a negative, remember, it becomes positive. So again, that's going to be 2 over 4. And then when I multiply that by 2, that'll be 4 over 4, which is a 1, and 1 minus 1 is 0. So now I'm starting to see a repeat here in my pattern. Pi, the value for pi, the cosine of pi is negative 1. So I'll have 2 times negative 1 squared minus 1. So it's going to be 1 times 2 is 2, minus 1 is 1. For 5 pi over 4, I'm going to get another negative square root 2 over 2, and I take the cosine of 5 pi over 4. So that'll be 2 times the negative square root 2 over 2. I have to square that, then subtract 1. So there again, when I simplify that down, I'm going to get 0. For 3 pi over 2, okay, now notice I have a 1 here and at pi, and then I've got zeros on either side of it. So my pattern should repeat. I should get a negative 1, and then a 0, and then a 1. Okay, so 3 pi over 2, when I substitute that in, the cosine of 3 pi over 2 is 0. So 2 times 0 squared, well 0 squared is 0, times 2 is 0, minus 1 is minus 1. Okay, good, that's the value I should get. For 7 pi over 4, I should get the same as pi over 4, I should get 0. So that's going to be 7 pi over 4, cosine of that would be square root 2 over 2. So I'll have the square root 2 over 2 squared. That's going to be 2 over 4 times 2 is going to be 4 over 4, which is 1, minus 1, which is 0. And then for the 2 pi, that's going to be the exact same thing as the 0. Okay, now remember we did get some negative values here, so that means we're going to have to go in the opposite direction for r when we're graphing them and plotting them. And remember, we're going to plot these points. It's all zeros and ones, but we have to connect them in a little bit of curve because it's got to look like roses, like petals or leaves. So it's not just a bunch of straight sticky lines. Okay, so I'll do a few of the points and then I'll connect a few. Right. So we're going to start at 0 degrees with 1 unit long. So that's over here. And then I'm going to go to pi over 4. Remember that's in the middle there. And I'm going to go back to 0. So what happens there is I kind of do like a little arc, like so. And then at pi over 2, if it was positive 1, I would go up to 1, but it's negative 1, so I'm going to go down. So that means I kind of go whoop, like that. At 3 pi over 4, which is over here, I'm back at 0. So I just connect and go back to 0. At pi, I'm over at 1. So my last point was at 0, so now I come over to 1. Now maybe you can see how the leaves are going to kind of take shape. At 5 pi over 4, which is over here, I am back at 0. So I connect back to 0. Negative 3 pi over 2, I have to go negative 1, so that actually means I go up 1. I go in the opposite direction. So I was at 0, now I'm going to connect up to the positive 1. 7 pi over 4, which is over here, but I'm actually going to be back at 0, so I connect my pedal back down to 0. And now, hopefully, you can really see what we're going to do next. For 2 pi, I go over 1, so I'm just going to connect from 0 to 1. So it's really, really small on this graph because, you know, this graph has 1, 2, 3, 4, 5 little rings on it. But you can see that it's got 4 little leaves or 4 little petals on this rose. And if we had a bigger value for this 2 out in front, okay, that would have made the petals longer. And that's actually what they talk about on the next couple of slides here. Now again, your book is going to want you to graph the cosine curve. You don't have to do that. This is just another way to think of those table of values. And they've numbered them in terms of how you connect them together. So I think you can look that over. If that explanation makes a little bit more sense, feel free. But again, they're starting at the same points and they're connecting 1 and then 2, 3, 4, 5, 6, 7, and then 8. So they do have the little arrows that help you see how to connect it. Okay. But don't number your graphs like that. Don't put 1 through 8 on your graph. That was just how they were helping you to see the direction. Okay. Here is where they talk about how you know if you have an even or odd number of the leaves. Okay. All of the rows type of equations are going to follow this format, the A cosine n theta. So we had cosine 2 theta, okay? And actually that number that stands for the n tells you if it's going to have an even or an odd number of leaves. So it says here an n-leaved rose, okay, if n is odd, or if 2n, oh, it's going to be an n-leaved rose if n is odd, and a 2n-leaved rose if n is even. So we had 2, so 2 was even, so then we took 2 times 2, so we got 4. Okay, because our equation was 1 cosine 2 theta. 2 is even, so then we multiply it by 2 and we get 4 leaves, or 4 petals on the rose. Okay. If it had been, you know, cosine 1 cosine 3 theta, 3 is an odd number, so then that's just the number of leaves that you have. Okay, so you don't necessarily have to remember that fact though in order to know what type of a graph you're going to get. You can still make your table of values and graph it and it'll work out. If it's an odd, you're probably going to get a lot more decimals. If it's even, you're probably going to have nice numbers on the axes. Okay, but you don't have to know this fact. It's good to know so that you can know the shape of the graph before you actually start to graph it, but it's not essential. Okay. So definitely practice these graphs. These are probably the most complex graphs you've done so far because it's a new system. You've never graphed polar stuff. You've never graphed little hearts or little roses. But again, remember your calculator can do this. Your calculator can double check it for you, but don't rely on that table of values in your calculator because it's just going to give you random decimals. Okay, so really take the time, make your table of values with your 0 to 2 pi radian measurements. Take the time to do that substitution, okay? And then remember that the solutions are worked out in the binder in the classroom. You can see them on the class website. And if you have any questions, come on in and see me before school.